So we're going to start with these axes, and the x-axis we will label quantity, abbreviate that with a Q, and you can also think of that as the firm's output. And on the y-axis we have the cost per unit. So I'm going to start with the marginal cost curve, and the marginal cost is going to equal the change in total cost divided by the change in output. Now, if our change in output is equal to 1, then the marginal cost is just the change in total cost. So how much does your total cost go up when you produce one more unit? And we're going to say that the marginal cost curve has a shape that looks something like this. Right now we don't have to have this area in here where it is downward sloping, but we know that at some point it's going to begin sloping upward due to diminishing returns. So I'm going to label this curve MC for marginal cost. And now let's move on to the next one. The next curve we face is the average fixed cost, and the formula for that is equal to the total fixed costs divided by output. So we will graph it. We're going to label our axes the same. This is the quantity or output axis, and over on the y-axis we have cost per unit, which I'm going to abbreviate CPU. Now, average fixed costs, they start out fairly high. In fact, if our output is equal to 1, then the height is equal to our total fixed cost. Okay, so we can plot a point right there. Now, if our output is equal to 2, then our point on the AFC curve will be half of what the original total fixed costs were. And as output gets really big, average fixed cost gets really small because total fixed costs don't change with output. So over here, say we had a number like 100, we're going to have TFC divided by 100. So that's going to be small. Now you see, as output keeps expanding, total fixed cost is going to remain the same. Quantity gets bigger and bigger. Average fixed cost will eventually get close to 0, but it won't be 0. And the curve is going to look something like this, and that is average fixed cost. It is always downward sloping when quantity increases. Next up, we have average variable cost. So with all these average something costs, we just take the total something cost and divide it by our output. So in this case, average variable cost equals total variable cost divided by the quantity. I'm going to keep the same labels for my axes. And average variable cost just looks like a U. I'm going to label this AVC, and for now that's it. It goes down and then it starts to come back up. Next up, we have our average total cost. So average total cost is equal to total cost divided by quantity. Label my axes, quantity on the x-axis, cost per unit on the y-axis. Average total cost also has this U shape, and it goes down and then it starts to come back up. So we will talk about why that is, and also its relationship to the other curves. We can also calculate average total cost as average fixed cost plus average variable cost. Next up, let's put them all together on one set of axes. So all of our axes were labeled Q and cost per unit. So order doesn't really matter here, but I'm going to draw in the average fixed cost first. So it looks something like that, and label it. Now I'm going to switch colors for the other curves, and I'm just going to draw marginal cost here somewhere. And it doesn't really matter where marginal cost intersects average fixed cost. We don't have any rules for that. There's no indication that it needs to be in one place or another. Next up, I'm going to draw the average variable cost curve. Now, average variable cost intersects marginal cost at the minimum of the average variable cost. So here's the minimum. I'm going to draw the curve coming up this direction and coming up that direction. I'm going to label it average variable cost. And then the last curve we're going to throw on top of here is the average total cost. Now, average total cost is equal to the sum of average variable cost plus average fixed cost. So we see in a quantity around here, I'll call it Q1, we can come up and we find that the average fixed cost is about here, and our average variable cost is about here. So basically what we want to do in order to find the height of the average total cost curve is add those two heights together. So what I'm looking at is we can basically take this height and add it on top of here and then figure out where we're going to put that point for the average total cost curve. So it should go somewhere around here will be our point for the average total cost curve. Now average total cost also intersects marginal cost at its minimum point. So I'm going to draw another point on this average total cost curve. Okay, so now I'm going to go over here to a different quantity. So you see at this quantity, the height of the average fixed cost curve is only about that tall. Right? So if we go to the average variable cost curve at this same quantity, then we can add this yellow height right here. So let's go up by about that amount. We can plot another point on the average total cost curve. We know average total cost is U-shaped, and it's going to be the sum of average variable cost, average fixed cost. It's going to bottom out when it hits the marginal cost curve and then begin to come back up. So the average total cost curve gets closer to the average variable cost curve as output increases. So if we take a look over here, this green height difference between those curves is different than the yellow height that we have over here. Alright, so here are all the curves together on one graph. So what you want to notice is that these intersections right here of average total cost and average variable cost, where they cross marginal cost, they are at the minimum point. And the reason is, if we come over to the left of this point right here, what we see is that at a quantity like Q1, the marginal cost is down here, the average variable cost is down here. So if we make another unit, we add a small number from this marginal cost to our current average variable cost, and that will bring the average down. And every time that marginal cost is below average variable cost, the average will fall. However, once marginal cost gets above average variable cost, so let's pick a quantity around here, call it Q2. At that quantity, here's our average variable cost, and then we can go up to the marginal cost curve, and we see that the marginal cost at that point is much higher. So what that's going to do is, if you produce another unit, you're adding a bigger number to your average, and that's going to bring your average up. Right? So you might want to think about this like your GPA. You have a semester GPA and a cumulative GPA. If your semester GPA is higher than your current cumulative GPA, that will pull your GPA up at the end of the semester. However, if you have a 3.0 right now, and you do poorly this semester, you get a 2.0, that's going to bring your average down. Right? So marginal means additional. Your semester GPA is just the additional GPA that you're adding to your cumulative GPA, which is basically your total GPA. Alright, so that is all the cost curves and how they interact with each other. Until next time, see ya.